Hi guys. So this is the third and final part of your CBA now. Once you've completed this assignment, you are going to be totally finished. Just to remind you, so this is my practice experiment as an example to show you what is required. As a reminder, my experiment, okay, I am going to investigate how the temperature of water affects how fast an effervescent, which is like a Barocca tablet, dissolves or reacts in water. You all have your own individual experiments. It is not the same as this experiment. Little bit of feedback from what I've seen from the last assignment on this. Some of you are getting very confused on this section here, so my research. This is a really bad example that I've seen from some students so far. They have given no source of information. They just put down that I thought of the experiment by myself, okay, and the author of the website was me, okay. That shows me that you haven't. Well, first of all, you haven't done any research, and second of all, that you haven't learned anything. Okay, two bad things. A good example here. Okay, your science book has got loads of really good information. Um, so I'm talking about the rate of reaction here. Okay, so I've looked up the rate of reaction in my science book, and I found out that increasing the temperature increases the rate of reaction, as it gives particles more energy. The more energy a particle has, the faster it's moving. Okay, so by putting this in, what I have learned, you have shown me that you've learned something while doing your research. And I've put down either the website and, in this case, the author of the book. The reason why that is so important is your hypothesis cannot be done correctly unless you have done some good research. So this is my hypothesis. If I increase the temperature, then the tablet will dissolve faster in less time. This is because, okay, some of you are writing very unscientific hypotheses. You need to have done good research, okay, which I've done here, in order to answer or make a good hypothesis using your scientific language. Right then, I'm skipping on now. Okay, so this is where I stopped last time. Now, some of you have actually gone ahead and started your experiment. That's okay. But some of you have, I've seen some results already. And if you just give me one batch of results, you only repeated it once, you didn't repeat it 2 or 3 times, I would be advising you big time to go back and do the experiment 3 times in total and get the average. So I've got my results here. I did my 3 runs for how long that the tablet was going to dissolve. For some of your CBAs, you won't have a table like this at all. Okay, that's no big deal. So for some of your CBAs, the best way that you might display your results is actually with photographs and things like that. I know some of you are doing plant growth, so photographs might be the best way to display that data. Now, really important, okay, I've got my temperature here and I've got the average time for the tablet to dissolve. The next thing I want to do, because the table here doesn't really show what's going on very well. So the best way to display this is to draw your graph. Okay, I want you to physically draw your graph on graph paper and you can take a photograph of that and put that in place here. Now, I have given you 11 key points to check to make sure that your graph is correct. First of all, if I graphed numbers against numbers, so what do I mean by this? So in this example that I've got here, I've got the time taken for the tablet to dissolve against the water temperature. So these are numbers on the y-axis and numbers on the x-axis. If I'm graphing numbers against numbers, I use a line graph. And this is an example of a line graph, okay? However, let's say I didn't have a thermometer for this experiment. I wouldn't have the temperature, the exact temperature. I might have just said it's cold, warm, and hot. In that case, if I'm graphing numbers, If I graph numbers against numbers, oh, mistake there. Against words, it's a bar chart. Right then, so here's another example. Here's the time taken for the tablet to dissolve. And this time I've done it in cold water, warm water, and hot water. So in this case, words, okay, on the x-axis against numbers, the best way to do that is with a bar chart. Now, from my results here, so this is from the data in this data table. And I can see clearly now that at 10 degrees Celsius, okay, it took quite a long time to dissolve, on average 180 seconds. But then as the temperature increased and increased and increased, the tablet took less time to dissolve every time. Here at 100 degrees Celsius, it only took like 30 odd seconds. But wait, there's one weird result here. At 80 degrees Celsius, I've got a red dot here. And this is called an anomalous result or an outlier. It doesn't really match up with all of the rest of the data. So if you get something like that, you should definitely highlight it. Don't ignore it, okay? Now, going on to a few more points in your checklist. Have you used a ruler and made sure that your graph is neat? Really important. Have I made the graph nice and big? Have I labeled both axes? Okay, so water temperature in degrees Celsius, time taken for the tablet to dissolve. Axes have to be labeled. Have I changed the cause variable on the x-axis? Okay, so go back up here. This is your cause variable. What will I change? I change the temperature. Okay, that has to go on to the x-axis here. Really important. I have included the units. I have correctly added a scale to my x and y axis. This means even spacing. Okay, I've plotted my points correctly and I've identified any outliers. Right, I'm just going to talk a little bit about this even spacing because a lot of people get confused on this. So I have put down here a really, really bad example of a graph. Okay, this is produced fairly recently by Fox News on the number of cases per day of people that were affected with the coronavirus. Now, Fox News is not a super credible, news channel, so it didn't really surprise me that they had a really bad example of a graph. Okay, on the x-axis here, they've got the date. Okay, that's fine. But if you look at the y-axis now, okay, let's check if they've got even spacing. First of all, they're not starting at 0. And your graph should start at 0, just like my graph up here, 0 and 0. So it didn't start at 0. And now let's check their spacing. They went from 30 to 60, so that's a gap of 30. 60 to 90, that's another gap of 30. And then 90 to 100, that's a space of 10, okay? And then they went again from 100 to 130, space of 30. 130 to 160, space of 30, space 30 again. Then they went from 190 to 140. That's a space of 50. I have no idea what they were thinking when they were making this graph, but their spacing is completely all over the place, okay? If one of you produced a graph like this, I would mark you down for it, okay? It's not acceptable. Now, moving on is your conclusion and your evaluation of your experiment. So I've written out my conclusion here, and you can get good ideas from this. So you have to make sure that you have described any patterns. So I've done that here. It can be seen from my graph that as the temperature of the water increases, the tablet takes less time to dissolve. Okay, let's double check that from our graph. As the temperature increases, as that goes up, it takes less time to dissolve. It's going down. So that's the kind of thing that I want you to be able to do. As one thing increases, the other thing might increase or decrease. What are your results telling you? Have I identified any anomalous results or outliers? So yes, I have. Okay, and I've talked about this here. And did I try explain the anomalous results, okay, the outlier. So I did try to explain it. So it may be possible that the water was not at the correct temperature when I did this experiment. Okay, maybe I made a mistake measuring the temperature here. So I've identified them, I've tried to explain it. Have I explained the patterns? Okay, so I've identified the pattern up here. Now I want to explain the pattern. So from my research, and this is why your research is so important, you're able to show that you learned something from your research, you learned science, and now you're explaining what you saw with that science. So from my research, I discovered that a Barocca tablet dissolving is a chemical reaction, and a carbon dioxide is produced. I found out that chemical reactions need particles to collide, so I've gone and talked about my research here. Finally, really important, have I shown that my hypothesis is supported? Okay, so repeat your hypothesis again, just like I've done here, and say, well, either yes or no, my hypothesis is either supported or not. In this case, my hypothesis is supported. This is what I predicted. It makes no difference if your hypothesis is not supported. Okay, in that case, you just say, no, my hypothesis was not supported. Now, you've done your conclusion. Pause for breath. Okay, you are on the final straight. You are almost finished your CBA. Now you have to talk about your evaluation. You have to discuss your strengths of your experiment, any weaknesses of your experiment. Discuss, are your results valid? Now, this is also, it goes back to your research. There's only one way that you can determine if your results are valid, and that is if your results are what you expected from what you learned during your research. So, for example, here, I believe most of my results are valid because I got what I expected from doing my research. Okay, that's the only way you can determine if your results are valid. Are my results reliable? Okay, yes, I believe my results are reliable because when I repeated my experiment 3 times, look here, I got pretty much in around the same answer for each run, so I do believe that my results are reliable. If you didn't, that's okay, and explain why you think your results are not reliable. As long as you explain correctly, it doesn't matter if it's reliable or not. Then talk about how could you make the experiment better or more accurate, and what further investigations you would like to carry out. Now, have a read through these, okay? And now finally, okay, how is your work graded? This is your success criteria. Okay, you are either going to get one of 4 grades. You might get exceptional, above expectations, in line with expectations, or yet to meet expectations. So this is like the worst grade you can get, yet to meet expectations, and this is the best grade that you can get, exceptional. So you want to check, okay, does my CBA have all of these points? Okay, or at least most of them. Okay, so have you formed a testable hypothesis or prediction with justification? Okay, really important. So if you follow our template, you should have all of these. If I have given you, or let's take for example here. So this for in line with expectations. Okay, have you displayed your data on simple tables or charts? Okay, and if you've made some mistakes or errors in the scaling or plotting of your graph, that would mark you down a bit. Okay, then you'd be going towards in line with expectations. So read through all of these, and you want to be aiming for the highest ones possible. So you want to be aiming for above expectations, okay, or even exceptional. That's what I definitely want to see. Right then. Finally, just before I let you go, okay, when you are submitting your work, I don't want any work submitted to me on chat unless there's an absolute emergency that your Teams is not working for some reason. Don't send me photos of your work. Okay, I want it typed up properly. And is there anything else? Not that I can think of. Okay. Hope you're having a very good Easter. And the very best of luck in finishing your CBA. All the best.